Welcome back, folks, to Scripting for Linguists. I'm your host, Earl Care Brown. I have a question for us today. The question is the Mojo language faster than Python when populating a dictionary with many words? Now, you may ask, what is the Mojo language? Well, I'll tell you what. It is the programming language for all AI developers. Mojo combines the usability of Python with the performance of C. You don't say. That's awesome. Okay. Why Mojo? Here's their page on their website about why Mojo. And they had no intention of building a new programming language, but they decided to do so because of AI stuff going on. So they say, because we require high performance support for a wide variety of accelerators, traditional compiler technologies like LLVM and GCC are not suitable, and any languages and tools based on them would not suffice. Nowadays, the standard technology for specialized machine learning accelerators is MLIR. MLIR is a relatively new open source compiler infrastructure started at Google, whose leads moved to Modular, the company building Mojo. Right? That has been widely adopted across the machine learning accelerator community. Awesome. Sounds great. Now, I've been watching this for the past couple months, 2 or 3 months, just kind of seeing what they're doing, just following the changelog as new minor versions come out. But I've been waiting for a native dictionary type. And very recently, before recording this video, they released another minor version of Mojo that has a new Mojo native dictionary type for storing key value pairs. Rah, rah. Here we go. Finally. So I can pit Mojo against Python, perhaps Julia, but mostly Python here. So that is my question. Is Mojo going to be faster than Python when just simply populating a dictionary in Mojo and then another script in Python with 230 million words? And to that end, I'm going to use my old friend, the Spotify podcast data set. You may or may not know at this point, that is a data set containing over 100,000 hours of audio and over 1 billion transcribed words. And I have about a quarter of it. I have 230 million words, I think, or is it 320 million words? Somewhere between a quarter and a third of that data set I have on my hard drive. Now, the way I know how to write Mojo right now is to have everything in one file. I do not see that they have a OS walk equivalent yet in Mojo. OS walk is a function in Python where you can walk down a directory, right? I don't think they have that yet. I haven't seen that. So what I've done is I've created one big massive file with all 230 million words in one TXT file, which is like 1.2 gigabytes big. And then that is in a TXT file on my hard drive called bigbadboy.txt. Let me just explain a bit of the code here. This is Mojo code. It looks very much like Python, right? This is a struct, and I don't think Python has structs, but and so what we're doing here, we can kind of jump down here. I'm going to read in a pathway. That's a string. It's going to return out a string, and I'm going to create a path object and read in the text with the .read_text method on that path object, save it out to a string, and then push it up to uppercase on its way out of the function. And then here's the getFreaks function. I take in that pathway, I create a vector, a dynamic vector, what's called a dynamic vector. It's kind of like a list in Python with a string as the data type of each element. I just split it up on a space. I don't think they have regular expression support at the time of recording yet. And so I'm just going to split up on spaces. And then this is the point of the whole video is right in here. I want to time this particular part of the script, which is create an empty dictionary, which I do on line 25. Here's my empty dictionary. Right, I have a string key type as the key type. I have an integer as the value type. Good. The var means that it's a variable that is mutable, that it can be changed after it's created, right? The let is that the variable is immutable, cannot be changed. So anyway, I just want to time this right here. Create an empty dictionary and then loop over the 230 million words and then just populate the dictionary with an if-else approach. If the current word is already in the dictionary, then add 1 to it. Get the current count, add 1 to it. If not, if the current word is not yet in the dictionary, then set the item to 1. Set the key to the current word, the value to 1. And just time that. That's all I want to time, is that simple step. Number 1, create an empty dictionary. Number 2, loop over 230 million words, populating the dictionary with frequencies. That's it. And then I print out the time there. This function in Mojo, the now function, returns nanoseconds, and so I have to divide it by 1 billion to get it into seconds. That's what happens there on line 33. That's all I'm timing, and then I just push out the frequency of the, just to make sure I'm getting the same frequencies, same frequency of the. And so, yeah, that's what I am going to do. Well, actually, I've already done. Let me show you the result. So here it is. Iteration 1 took 243 seconds. So that is 4 minutes and 3 seconds, right? 4 minutes is 240 seconds. So, yeah. Right, 4 minutes is 240 seconds, so that's 4 minutes and 3 seconds. The second iteration took 249 seconds, almost 250 seconds. So that would be 4 minutes and 10 seconds. So 245 is the third iteration, 244, and 246 for the fifth iteration. I only did 5 iterations here because it takes a little bit longer. So I only did 5 trials in this video. Okay, so I basically translated that Mojo script that I wrote, which is the best I could do right now, how I understand Mojo works. Translated that into Python. And let me show you my Python code. It shouldn't be too hard to understand. Basically doing the same thing. I'm opening up the file connection to that big bad boy text file that has 230 million words in that one text file. And it's 1.2 gigabytes big. I uppercase it. I split on on a space character like I do in Mojo. And then again, I'm only timing this one little component of this thing, where I create an empty dictionary on line 8. I loop over the words on line 9, and then I just populate the dictionary. If the current word is already in the dictionary, then grab its count and add 1 to it. If not, then add a new entry to the dictionary and give it a value of 1. I'm just only timing that. I just want to hone in on populating a dictionary with a lot of words, many words, right? And good. And I also return out the value of the frequency of the, just to make sure I get the same results from Mojo and Python. Again, I'm going to do 5 iterations just to have the same number of iterations as I did in Mojo. And the results are sitting right here already. I did it before I started the video. So here's the result of iteration 1, 34.5 seconds. Iteration 2 is 34 seconds. Iteration 3, 34.1, 34.9, 35.0. Whoa, okay, that's a lot faster. I don't know if you remember the numbers from before. Let's take a look at those numbers. I have them sitting right here, ready to go. Okay, so those are the 5 numbers in red here on the top part of the spreadsheet. Let me zoom in a bit more here for us. Those are the 5 numbers, right? 243 up to 249. So right between 240 and 250 seconds. So between 4 minutes and 3 seconds and 4 minutes and 9 seconds, or almost 10 seconds, is what I have in Mojo. And then in Python, down here in yellow at the bottom part, I had values right between 34 and 35. Right, 34.0 was the fastest and 35.0 was the slowest, right in the 34 range. And so I've already calculated the mean and median of those 2 sets of 5 runs. So here is the mean on the right-hand side on cell E5. I have the mean for Mojo was 245.9 or 246 seconds, and the median was 245.5. Right? There's not many outliers, and so those values are really close to each other. That's also the case with Python at 34.5 seconds. Okay, wow, that's a lot different. That is smokingly faster in Python. Just to make sure we understand how fast that is, let's do a little calculation. If I take this number, 245.95, divided by the mean in Python there, wow, okay. I'll do the same thing with the median just for good measure. Take the median in Mojo, divided by the median in Python, enter. Okay, we're getting 7.1. It took Mojo over 7 times longer to populate the dictionary with 230 million words. I do not know why that's the case. I have no agenda here. I simply had this question. Right, the question I had was this: is the Mojo language faster than Python populating a dictionary with many words? I really honestly do not know why I'm getting this. If Mojo is supposed to be smokingly faster, I am missing something. There probably is operator error. It's probably my fault. I'm going to leave a link in the description below this video to my Mojo script and my Python script. And please help me, viewer. If you know Mojo and you know Python as well, especially if you know Mojo Dictionaries, a new thing that came out very recently, please help me out. I'm not sure why I'm getting 7 times slower in Mojo than Python. That is super weird to me. I was expecting it to be smokingly faster than Python, and so I'm not totally sure why. So if you know Mojo, please take a look at my scripts. Again, I'll leave a link in the description below. But to answer our question, is the Mojo language faster than Python populating a dictionary with many words? The answer here with my test is no, an emphatic no. It's 7 times slower in Mojo than Python. Again, I'm super confused. I'm wondering if there is, I assume there is some type of operator error. That is, I did not write the best Mojo code. I just wrote what I knew, how I knew how to do this in Mojo, which is here. Again, I'll leave this in the link to this in the description of the video. So yeah, what do we say here? Well, I say Mojo seems to be a new kid on the block, shiny and bells and whistles and stuff. And I'm not sure yet how to make it faster than Python with a common linguistic task of getting frequencies of words in many words, get the frequency of many words. So please help me out. Thanks for watching. See you next time.